This video is going to focus on the kinds of things that you might need in addition to what we've already done in the first video for chapters 2 and 3. In particular, I showed you one of these things already a little bit, but I'd like to show you one more time. If you have an equation, so let's see, like on the, you know what, I'm going to make one up. Let's say that you wanted to find the change, percent change in average rate of change. This is section 2.1 of just a simple equation, 5x squared minus 3. And we'll just do this between 2 and 3, I guess. So we're going to do vars, y vars function y1 of 3 minus vars, y vars function y1 of 2. I said between 2 and 3. So this would be the change between these intervals, 25. Now there's a really cool feature. If you hit second and you hit enter down here at the bottom, or entry right here, it will pull up the previous line of text. The reason that matters is because sometimes it's really nice to be able to pull that back up and to use it for something. So for instance, this is how we found change, and if you wanted to find average rate of change, then you could put in parentheses. So you can get a parenthesis right here by doing second insert and a parenthesis. And then to do average rate of change, you would divide by, and it would be 3 minus 2. So obviously in this, not very exciting, but just so that you can kind of see the calculator strokes. Of course, it still gives you 25. You can actually go back and you can pull up the previous entries several times back. And so let's say then you wanted to do percent change. So percent change would be to take this value. We're again going to use second insert parenthesis. And you want to divide by vars, y vars function y1 of the second entry. So that's y2, the original value. And then you would hit enter and then times 100. So that would be an example of how you find percent change. The next real big component actually doesn't happen until chapter 3. At the end of chapter 2, we're looking at finding what's called a derivative or an instantaneous rate of change. But when we get into chapter 3, there are some formulas for finding them in simple ways and so forth. But what I'd like to show you is I'd like to actually show you how you can use your calculator to verify your answers. So let's say you've got this and you're going to find the derivative. So the derivative actually is in math number 8. And you can arrow down, I'll do it just so you can see it says inderiv. Now, no matter what version of the calculator you have, it's going to say that. Yours may or may not look like mine when you pull it up. So let's say that it does, and I'll show you what it looks like, and then I'll tell you what to do if it doesn't. If it looks like inderiv, you have to tell it what's the function you want the derivative of. Well, we want the derivative of whatever we put into y1. We want to put a comma x, that tells us what the variable is, and then a comma and then where we're wanting to evaluate the derivative at. And I'm just making things up here, so let's just say it's at 5. And you close the parenthesis and it finds the derivative for you at 5. Now, if for some reason that's not what you were looking for example, you actually, not what you were looking for, I mean, it's not what your calculator showed, right? It doesn't say inderiv here. What might it say? Well, it might actually say a blank spot and then have a line and then a D and another blank spot here. That's how it might look. And if it does, here's what you do. You put in y1 here, you tell it dx here, and somewhere over here, I can't remember what it looks like because my calculator doesn't look like this, there's a place where you enter what the x value is, x equal to 5. It's not quite like this, but there's a portion of it that you have there. So you clearly are entering y1 right here, you're clearly telling it you want the derivative with respect to x, and it's at x equal 5. Maybe there's a parenthesis here, that may be what it does, I can't remember. At any rate, you're telling it the value that your function that you're evaluating it at. And there's one more in here too, I think, that asks you for the percentage change when you have a derivative. And you can do that the same way. You still find inderiv, so you do math, like we just did here, the inderiv, and then you divide by the actual function value, same way, at that function at y5, and then times 100. So that's how you find percentage change when you're looking at that. Let's see if there's anything else in chapter 3. I think that's it.